What's up, guys? I'm going to do a real quick Lab 1 solution just so we can go over everything that we were supposed to in Lectures 2 today and make sure that it's really easy to understand everything that's going on in this lab and what you need to know and do in order to solve it. So, what we're going to first do is we need to include the standard input-output library. So we're going to do a preprocessor directive to hashtag include standard input-output.h or std io.h, and we're going to then do int main. There should be no parameters, so void means that there are no parameters on the next line, and then doing our curly brackets. Since this is an int function, it must return a number. We're going to have it return 0 when it successfully executes, and now we can comment out that we're going to do our function declarations and our executable statements. So I'm going to real quick throw this over to one side of the screen, pull this up so we can then get our lab information. Now ignore pages 1 through 4 and page 6 and the first half of page 5. The only thing you need to worry about is going to be the problem and then the example executions here. So what we're going to see here is a given planet that orbits a single star is expecting to experience an eclipse that will last 60 minutes as viewed from its capital city. Engineers in the capital city estimate that the percentage of the star obscured by the natural satellite of the planet is determined by p for percent equals minus 0.11 times t for time times t minus 60. Furthermore, the brightness is a linear function of the percentage of visibility, as brightness equals 7.99 times visibility plus 126.7. And if you notice here that it says the percentage of visibility, which just happens to be exactly what we the percentage of the star obscured, would then be 1 minus this would equal v. So if we want to real quick throw this into comments so that we can keep track of all this, let's do a multi-line comment here by doing that and then that. So that's just a multi-line comment right there so that you're able to, anything between those will be considered a comment. So percentage obscured is equal, and this is just pseudocode, this is not code, this is just making it easy for us to remember this as we work with it. So the percent obscured is equal to minus 0.11 times t for time times t minus 60. We need to remember that visibility, or the visible percent visible, is equal to 1 or 100% minus percent obscured. And then for the final one, that the brightness of the star is equal to 7.99 times visible, or percent visible. Let's keep this uniform so it's easy to follow. Percent visible plus 126.7. So we need to also remember that we're going to have 3 steps here. So on each of the example executions, we're going to have the user enter the minute of observation, enter the time, and then from that we're going to calculate and print out the percentage obscured, and then the current brightness. Excuse me. So we're going to have 3 print statements. So let's go to our executable statements because we have now included printf, so we can do printf, and we'll copy and paste this 3 times for each of the 3. And there's a little bit of indentation error there, so we're going to fix that just so that we're uniform and it makes this easy to follow. So on a new line, we want to say, please enter the minute of observation, and remind the user we want it to be in the range of 0 to 60. and we notice this all highlights green, so that means that this is successfully going to print, except for blue because that is \n, which is a key character. So then we're going to go on a new line then, and we're going to do percentage obscured is, and then we see this as a floating point there, so we're going to do a %f because we want to use a floating point. And it then says at time, and then this is going to be a whole number because we see in all of those this is always a whole number. So we're going to do %d, which is the format specifier for that. Then finally, another new line. We're going to put in current brightness at time %d because we're dealing with a integer right there again. That is a whole number integer. At %d is expected to be, and then again we're dealing with a float, so we'll do a %f for floating point variable. And now for all of these we need to specify the identifier that these format specifiers are referring to. But in order to do that, we're going to have to first go into our function declarations and declare some variables. So we see we need %obscured, %visible, brightness, and time, right? So we're going to have int time, and we'll do float for floating point. There's no need for double precision on this specific example. Float %visible _visible, and make sure that you're using the same naming construct on all of these. Everything should be lowercase, and then there should be an underscore in between the names. So there's %visible, float, %obscured, and float brightness. So now that we have all of these defined, we have the first statement here. Let's make this full screen so it's a little bit easier to see. And we're going to then go and scanf in, write in the user input. So we're writing in here a whole integer number, so we're going to do %d because that's the format specifier, and then we're going to do time. But see, you have to use here the ampersand for, the ampersand is the address identifier. So the construct for this specific function is that it will take whatever meets this format specifier requirements, and it will then write it into the address that is specified here. It just is looking for an address to store this. However, if time has a value in it, whether it's 0 or a leftover value from a previous program, that's a physical place in memory, right? So it's going to, whatever that value is, as soon as it sees t, it will go and look at the value of t. If t is 0, it will go to address 0 and store that value. If t is some random number, it will go to whatever that, it will treat that as the address and go to wherever that is. However, we don't want that to happen. We want to go to the address of the identifier time, the address that that identifier represents, and we want to write it there. So this ampersand is the address operator. So it says the address of the identifier time. And so because we are now putting in the address of the identifier time, it will now read in whatever the user inputs into then the address of time. So then the value of time will then become that number. Hopefully that makes sense. I know it was a little bit complicated. Addresses in memory are a little bit difficult to grasp, but hopefully this will make it a little bit easier for you to wrap your brain around. So now that we have the value of time, we now need to calculate out the percentage obscured, the percentage visible, and then our brightness, right? So the percentage obscured, let's do percent obscured, is going to be equal to minus 0.11 times time times then time minus 60, according to the equations given. So now that we have calculated that out, we now need to figure out the percent Actually, let me do the other step first so it's easier to follow. So the percent obscured is percent f at time percent d. So reading left to right, percent f would then be percent obscured, and percent d is going to be time because that's what we're trying to do. So we'll put in time, so it'll look at the value represented by this identifier, substitute it in place of percent f, see the value represented by the identifier time, substitute it in for percent d, and then print that. So let's real quick comment this out and run what we have so far. So please enter the minute of observation. So let's do 10, and the percent obscured is 55 at time 10. If we go back to the other page, we can see here that the minute of observation is 10, and the percent obscured is 55 at time 10. So now we can move on to this next statement. The printf here, current brightness at time percent d is expected to be, and then it is going to be percent f. So we already know that at time percent d, we already have time, so we can substitute in that identifier for the first one, because again, we're reading left to right. And the second one is going to be the current brightness. So if we're doing brightness, we know that brightness is equal to 7.99 times percent visible plus 126.7. Well, percent visible is equal to 100% minus the percent obscured, correct? So the whole minus the partial. So what we have to do before we're able to calculate this equation is we have to calculate this equation here, the percent visible equation. So the next thing we're going to do is define percent visible. So we're going to make that equal to 100 minus percent obscured. Because as you see here, in our test case, the percentage obscured is 55%. So 100 minus 55 will be 45. That'll give us the percentage that is visible. Now we can calculate the brightness. So going to new line, we have brightness there, and that will be equal to 7.99 times percent visible plus 126.7. Make sure that we keep our construct of having one space in between each math operator the same. And then we can put in here brightness for that second one. So if we run again, we should be able to put in 10, and we get 486.25 as that second number at time t. Going back to the original, we have 486.25. So we have all the correct numbers. There's just one little thing that we can see is not correct, and that is, we see here this is 55.00, and this is 486.25. Well, this has a lot of zeros on the end, and this has a lot of zeros here. If we look at this PDF, we can see that in all of these examples, it is always 2 decimal places on both of these that we want to format it for. So if you refer, excuse me, if you refer to the course resources, you can see all of the formatting for, and I'll link below, all the formatting for these format identifiers. And what is what is key, I'll just mention one right now, is that the decimal point, there is a length modifier and there is a precision modifier. The length modifier is the minimum number of spaces reserved for the entire number, and the precision modifier is the number of decimal places that we're going to reserve. So after that, it will round it. So we only want 2 places here. So if you put after the percent sign before the f, .2, that means that there are 2 places on to the right of the decimal point that it will reserve when printing out that value. So if we change both of these percent f's to %.2f, that will now make it that there are 2 places to the right. And I can demonstrate this also, that you can do this with any number. So 3 now becomes that there should be 3 on the first percentage obscured and only 2 on the second one. So let's real quick run, and let's put in 10 since that's the numbers we've been working with. We can see 55.000, so there's 3 zeros as we specified there, and 486.25. we have 2 specified to be to the right. So since the lab called for there to be 2 to the right, we can now run, enter in 10, see that we're getting the correct numbers in the correct format. And if we then throw this over here, look at our other test cases, we can slide this out of the way, clear, run. At minute 30, we're going to have 99, and 134.69, 134.69. Let's run again. We can do minute 0. We're going to get obscured is 0.00 at time 0. We can then get 0.00 at time 0. Time 0 is expected to be 925.7. Time 0, 925.7. And for the final test case, minute 60, percentage obscured is minus 0.00 at time 60. Current brightness at time 60 is expected to be 925.70. So we have all those. The only thing is that this minus 0.00 is a little problematic because we don't want that to be a minus, correct? So what we're going to do is do one last thing. There's one other function you should be aware of. So the percentage obscured is percentage obscured. It's called the absolute function. It takes the absolute value of a variable. So we can put abs around that. Ab stands for absolute. And now it will take the absolute value of that, and that should get rid of the minus. So we're going to do at time 60, 0 at time, this is screwing up, but everything else seems to be working correctly. So not sure exactly what happened right there. Might just be a glitch, but we can see that we are getting all the correct numbers for this, and we have the correct solution. So if you have any other questions, please do drop them down below. Comment, subscribe. Thank you for watching. It's been wonderful working with you guys, and I look forward to the future lectures and lessons. So once again, please like, comment, and subscribe. Thank you for watching, and I will see you next time. Bye-bye.